Dr. Inbal Talgam Cohen is a faculty member in the School of Computer Science in Tel Aviv University and a visiting faculty member at the Technion's Computer Science Department. And she's here to talk with us about principal-agent reinforcement learning. Liz, welcome her to the stage.
Okay, so thanks very much for the introduction. Thanks for sticking around this far into the session. My topic is reinforcement learning with contracts. And I guess you guys know a lot about reinforcement learning, so I'll start with the contracts part. You also know about contracts, right? We all have, maybe an apartment lease or something like this. The contracts that I'll be referring to is, as they're defined in economics, it's a beautiful and deep mathematical theory, and let me tell you a little bit about it, starting with an example. So suppose that you're a brand, and you want to hire some content creator for your brand. Of course, creating content requires some effort, so you're going to have to pay. And what you see is the outcome of the effort. So maybe you see the number of views or clicks that the content got. But this is uncertain. Okay, it depends on the effort, but it's uncertain. Maybe you have some beautiful content that took a lot of effort to make, but something happened in the world that day and it doesn't get any attention. Okay, so the other way around can happen as well. The question is, how should you pay the content creator for their effort? Okay, and contracts give us a tool, a theory, to design such payments. The idea is going to be that you want to tie the payment to the performance, okay, to the quality of the content that was created. For this talk, we'll also be interested in the case where the content creator is an AI. Okay, is it necessary to incentivize an AI the same way you might try to incentivize a content creator who's an agent, who's a human agent that's working for you? Okay, so we'll be interested in this kind of questions. So what's a contract in economics? It's an economic tool for aligning incentives, okay, a tool for alignment. Already sounds good, right? It's a very deep theory. It won the Nobel Prize in 2016. The idea is to get an agent. Okay, we have rational players here. This whole talk is kind of covering the incentive side that Ishai was mentioning before. So all the agents, I'll refer to them as players. They're rational, trying basically to maximize their utility in the way that they act and decide. So the contract will get the agent to invest effort in a project, even though it's the principal's project. And the way it does so is by paying the agent for the outcome of their effort. The effort itself is something that's hidden from us. We can't pay directly for it. If you have employees, people who are working for you, students who you're working with, you know how this goes. You see their outcome. You don't know exactly how much effort they put in. And this creates moral hazard, meaning that the agent will want to appear as if they put in a lot of effort, but maybe not put in that much effort in practice. The payments don't have to be monetary, right? You can pay by some kind of badge system, some kind of grades, if it's a school setting, and so on. Okay, and contracts, so I mentioned there's beautiful theory that won the Nobel Prize. They also really matter in practice. There's some anecdotal evidence that the quality that you get if you hire an online freelancer is maybe not great. And it's confirmed by a rigorous study that this is a problem of moral hazard. I want to mention there are other solutions to the problem of not getting quality work. You could rely on recommendation, reputation systems, on the legal system. All of these systems have their own issues. And I think a very straightforward thing to try first is to use contracts to align incentives between the agent and the principal by paying for the performance. Okay, that's the economic part Now I want to tie this to AI, giving a couple of examples, and the third one will be reinforcement learning, and then I'll dive deeper into that. Okay. So what's a possible use of contracts in AI? Here's one example. So delegating text generation is something that we all have started to do, where we're delegating to AI agents like ChatGPT. In the last January, people started noticing that ChatGPT is becoming lazy, okay, quote unquote. And I don't think up till now it's even clear what exactly happened. The OpenAI say that they didn't make changes to the model. But I think this example kind of gives you the idea that maybe it's a good idea that the way that we pay for generated content will be tied to the quality. Okay, right now, we have very simple payment methods like pay per token. Maybe we can do smarter things and then kind of incentivize ChatGPT through the economic incentives of OpenAI not to go lazy, to become lazy. Here's another example. Say we have delegation of some of the machine learning pipeline, in this case, classification. We have some hospital and some AI company. The hospital asks for a new AI for cancer detection and states their budget. The AI company says, sure, pay us the budget in advance, we'll train a classifier for you. A month goes by, and the company delivers the classifier like they said they would, but it's totally inaccurate. And it's not clear, this is the uncertainty and the noise we were talking about before. It's not clear if it's very inaccurate because detecting cancer is hard, a hard problem, or because the payments were not designed, the contract was not designed in a good way. I mean, this seems a bit silly, right? You state your budget and you just hand over the budget. You don't tie it to the performance. That's not a good idea. Okay, and the theory of contracts gives us the tools to do better, especially when we add in computation, but that's for another talk. Okay, and now for the connection to RL. There are situations where you want to delegate something in a more complex setting, right? We saw up till now, you have like the single task that you delegate to an agent and they return something back. But it could be the case that agents have to learn to perform some multi-stage task that involves uncertainty. And this task is delegated to them by principal, and the principal is the one who reaps the rewards and has to pay, of course, the agent for their efforts. I listed a few examples on the slide. Drivers who are exploring routes are benefiting a navigation app. Users who are rating online content are benefiting a website. Students who are training through an online course are the goal of the instructor is for them to actually learn and put in this effort. And an example that we'll be returning to in a couple of slides is the one of AI agents who are learning some collective action, okay? For example, learning to together clean up some space or harvest, make the most of some joint resource. And in this case, the principal, the one who is trying to kind of delegate the work to these agents, will refer to them as a social planner. And the goal of the principal will be to kind of coordinate the agents, pay them so that they get the job done in the best possible way, okay? Okay, so I want to dive deeper into this idea of contracts and RL by presenting some joint work. It was led by Dima Ivanov, who we see on this slide, and some other folks from Google Research in Harvard. Let me show you the setup. So in our setup, we have an agent who is trying to learn a policy for a finite horizon MDT on behalf of a principal, okay? So here you see just a single state. Okay, let's first focus on a single state. The agent can either go left or go right. The actions are noisy in the sense that if the agent tries to go left, they might end up being left, okay, with probability 0.9, but they might actually go right. Okay, this is because actions, even if you put in effort, you might still kind of fail. Okay, let's say we want to go left in this case. Going left is what takes effort, but sometimes you make effort and you fail. Sometimes you don't actually make effort. Okay, you try to go right, but you end up succeeding to go left. Okay, so this is a single state. And now, let's add on some more states. Oh, and wait, so in a single state, the idea will be that whatever the agent did will give some reward to the principal, okay? And so in this state, there will be a contract that is trying to incentivize the agent to go left, okay? Now, we can make this more interesting by adding some more states, making it a full-blown MDP. In this case, this is like a toy example. I just multiplied 3 times the state. Okay, and in each one of these states, we will have a contract. And the idea is that the principal will also be learning these 3 contracts. The principal will learn to guide the agent by a series of contracts, 1 per state. Okay, that's our setup. What we do is we have an algorithm, which I'm not sure I'll have time to show you, but we have an algorithm that is kind of like a general method, and we also instantiate it and run it in practice, that manages to learn policies both for the agent for traversing this MDP and also for the principal. Okay, that is these contracts that incentivize the agent. And the two policies form an equilibrium. You all are familiar probably with this prisoner's dilemma game, so you know the concept of equilibrium. Basically, it's a steady state where each player doesn't want to change what they're doing, and it doesn't have to be necessarily a good one. But we choose a kind of equilibrium called the subgame perfect, which has some nice properties, and our algorithm manages to find such policies. Okay. And our application is to solving social dilemmas like the like the prisoner's dilemma, but more complex. So here I'm just showing the simple prisoner's dilemma, sorry. This is the basic game. And of course, as you all know, both players will defect, and it's not a good outcome in terms of social welfare. The idea is that through payments, okay, if you kind of boost the payments of the agent in a way that the principal can plan and carry out and can learn how to do that, then you get both of the players to cooperate. We take this simple idea and we apply it to sequential social dilemmas, okay, that is good. That is kind of extensions of the prisoner's dilemma to multiple time periods and complex state spaces. And we train the principal to maximize the social welfare through contractual payments, and we want these payments to be minimal. Okay, it's not very hard to get people to do things if you pay them a lot of money. We want to minimize the payments. So what you see here is an example from a different work, which started to carry out this idea. They had robots who were cleaning the river and had to cooperate. In this case, they didn't have a principal. Okay, and what we show is that if you have a principal who's kind of coordinating the agent and planning the payments together, we can get good results. We apply this to some social dilemma called the coin game, and let me finish with these results. So what we show is we look at the coin game without contracts and with contracts. The green one is without contracts, when each agent is kind of selfishly doing whatever they want to do. The pink is the optimal baseline. That is, if the agent were trying to, forgetting about their own selfish interests and really working somehow, magical agents who are working for common good. Okay, and what we get is this orange line. So you see, the learning is quite good here, and we managed to get very nice social welfare while not paying too much. Okay, not paying too much. I can say more, but I'm more or less out of time, so let me sum up. If anybody is interested more in the approach and the algorithm, I can tell you more later. I want to sum up just with the potential impacts I see to using contracts in AI. First of all, alignment. Okay, AI agents. We want them to truly work for us and to cooperate. And I think looking to economics for that is just very natural and could be very rewarding, to use this word. And of course, just improving markets for ML services, better pricing, and so on. Thanks so much. Happy to take questions.
Thank you. First question. Why is Dima Ivanov on the market?
Oh, yes, thank you for reminding me. He's wrapping up his beautiful postdoc, and he's on the job market. Check out his website. He's looking for research positions in industry. Thank you.
Thank you. Any questions other than about Dima Ivanov?
Yeah.
Which of the goals, like how to get to a combined social benefit. So in here, like you mentioned that there's principal goal, which is like the pay as possible, and then fees goal, and you're trying to say, okay, this is like a good position somewhere in between. How do you actually define where to place the optimum? Because it's
Yeah.
both ends of the.
That's a great question. So there are multiple players, and if you look at the world through each player's perspective, you have different objectives. What's nice about the social welfare objective is that it kind of, or even mathematically, in a very precise sense, it sums up the utilities of all of the players and tries to maximize that. So I think that's a good goal to start with. That's what we do for the social dilemmas. But our goal is to build tools that you can kind of you can feed in whatever objective you are interested in that point, and get the contracts that will maximize that. We look at the world from the designer's perspective. Maybe is a good way to put it.
I really apologize, but we're drawing late, and I would like to ask the audience to ask you questions later. I apologize about that.
Yeah.
And thank you so much.
Thank you.
For all of you.